In Unit 4.3, we're going to learn how to solve for angles of polygons using the interior and exterior angle sum theorems. The interior angle sum theorem tells you that the sum of the interior angles of a polygon is equal to n minus 2 times 180. In other words, you take the number of sides, subtract it by 2, and multiply it by 180, and that'll tell you what all the angles on the inside add up to. The exterior angle sum theorem tells you that the sum of the exterior angles, or angles on the outside of a polygon, all add up to 360. So no matter how many sides it has, the exterior angles will always add to 360. Here I have a picture to show you what the interior and exterior angles of polygons look like, and a chart that shows you the sums for different types of polygons. So again, for the interior angles, you can always use n minus 2 times 180, where n is the number of sides. If you only want one of the interior angles, you would use that same formula, but then divide by n at the end. So divide by the number of sides to find how much one of those angles is. And the exterior angles always add up to 360 no matter how many sides there are. So we're going to do some practice problems using these theorems. Problem 1 says a polygon has 13 sides. So our n is equal to 13. And we want to find the sum of the interior angles. So we're using the interior angle sum formula, which is n minus 2 times 180. So I can plug in 13 for n. This becomes 11 times 180. If you do that on a calculator, you'll get 1,980 degrees for the sum of the interior angles. For question 2, it wants us to find the measure of each interior angle of an octagon. So since octagons have 8 sides, n is 8 for this problem. This time they want each interior angle. So we're still going to use n minus 2 times 180, but we're going to divide by n at the end to get one angle. So instead of the sum of all of them, you just want one. So I'm going to plug in my 8. 8 minus 2 is 6. So if we do 6 times 180, that comes out to 1,080. And then you would divide by 8. And that would come out to 135. So if you have an octagon, each angle in the octagon on the inside is equal to 135 degrees. Our next problem wants the measure of an interior angle. They're telling us the measure of an interior angle is 120. So they're already giving us the answer. This time they want the number of sides. So this time we were trying to figure out what n is equal to. They told us that one angle is equal to 120. So we're going to use the same formula from the previous problem. But this time, instead of plugging in for n, we're going to set our formula equal to 120 because we already know what that angle is equal to. So it's like we're going to solve or work backwards. So I have an equation that I can solve for n. Since they're dividing by n here, the opposite would be to multiply both sides by n. So I get n minus 2 times 180 equals 120n. My next step, I'm going to distribute to get rid of parentheses. So I get 180n. 180 times 2 is 360. So now I'm going to copy this problem over here. And I'm going to solve for n. So since I have n on both sides, I would want to get rid of one of those. I'm going to get rid of the 180n. And then I can divide both sides by negative 60. So we do negative 360 divided by negative 60. We get 6 as our answer for n. Remember, n is the number of sides. So for this problem, there would be 6 sides. So it would be a hexagon. So Since they told us one angle was 120, again, what we did was we used the formula, but this time we worked backwards. We're going to try some problems using the exterior angle sum theorem, which is a little bit easier because the exterior angles, again, always add up to 360. So this problem says the sum of the exterior angles, it wants the sum of the exterior angles of a 27gon. So remember, no matter how many sides a polygon has, the exterior angles are always going to add up to 360. So here the answer is 360 degrees. We didn't have to do any work. Our next problem says find the measure of each exterior angle of the hexagon. So here we have to do a little work because they only want one of the angles. And remember, hexagons have 6 sides. So here we know the exterior angles add up to 360. If we only want to know one of them, we would divide that by the number of sides. So each exterior angle would be 60 degrees. So basically, if you want one exterior angle, you do 360 and you divide it by n, the number of sides. This last problem is going to tie several things together, and we're going to be using algebra. So this time they gave us a drawing. This is not a regular polygon. It's one where all the angles are different, but you can still use the sum theorem. So here, since we notice all the angles are on the inside, we can use the interior angle sum theorem because we know if we know the number of sides, we'll know what all the interior angles add up to. So this polygon has 5 sides, so it's a pentagon, so that means my n is equal to 5. And I can use my interior angle sum theorem, n minus 2 times 180, to figure out what all those angles will add up to. So this will come out to 540 degrees. So all the angles in this picture add to 540. So what I could do now is I can write an equation where I add all the angles A, B, C, and D and set it equal to 540. So I'm just going to do that going across, starting with A. So I have 4x plus 10. And then for B, I have 6x plus 10. For C, I have 5x minus 5. For D, I have 4x plus 5. And for E, I have 7x. And what I can do is I can add all of these together to get one expression. So if I add my x's together, I get 26x. And if I add my constants together, 10 plus 10 is 20. Minus 5 is 15. Plus 5 is 20. So this becomes 26x plus 20. And remember, all of those angles we found out we're going to add up to 540. So I can set this equal to 540 and now solve for x. So now I know my answer for x. And once we know our answer for x, we can actually plug that in to each angle to find the individual angles. So if I start with A, I would do 4 times 20 plus 10. That's 80 plus 10 or 90 degrees. So I'm going to write that on the side here. Angle A is 90 degrees. Now let's find angle B. If I plug in 20, that's a 120 plus 10 or 130 degrees. Now for angle C, I'm going to plug in 20 again. 5 times 20 is 100, minus 5 is 95 degrees. I'm going to continue with angle D. This is going to be 4 times 20 is 80, plus 5 is 85 degrees. And lastly, we can do angle E. 7 times 20 is 140, or 140 degrees. So here the main thing we did is we saw that there was 5 sides. So we found the sum of the interior angles by doing n minus 2 times 180 and found that was 540. Then what we did is we added all the angles on the inside and combined like terms to get an expression 26x plus 20. And since that's the sum of all the interior angles, we could set that equal to the 540 degrees and solve for x. Once we got our answer for x, which was 20, we plug that into x and all the individual angles to see what each angle in this figure was equal to. So to summarize, there's a few formulas you want to remember here. If you're finding the interior angle sum, you'll use n minus 2 times 180. If it's just for one angle, you would divide that by n. So n minus 2 times 180 divided by n. If you're doing the exterior angles, they're always going to add to 360, no matter how many sides. But if you want to find one of the angles, you would divide 360 by the number of sides.